Number 2, here we are with a brief intro to graphing. We've had a busy day doing the ISASP test the first half of the day. We're getting our test back, and we're just setting the groundwork here for our graphing unit today. And then you should hopefully have some free time to work on some remediation work, whether for this last test or an older test. And if you are all caught up on work and assessments, fantastic. And you'll have some free time at the end. But we're just starting to talk about and think about graphing, sine, and cosine. And when we're graphing, like we talked about with the unit circle, these just keep going around and around and around. So our graph's going to go on and on forever. Some key points to think about are, where do we cross 0 on our graph? What's the highest we get and what's the lowest we get? So for sine, on our unit circle, because we're just kind of unwrapping the unit circle and putting it on an XY grid going left and right, what is the biggest value for sine? Our biggest value for sine is 1. We'll have 0, 1 up here. And we'll do sine in degrees, just to kind of keep it easy for you right off the bat. And then we'll switch over to radians for cosine. So our max value for sine, the highest we get is 1, and that was at 90 degrees. Sine is 0 at 0 degrees and at 180 degrees. And the lowest sine gets is -1 at 270 degrees. Okay? Now, the other points are nice to know, but they are not essential to making the most basic graph here for sine. Alright, so at 0 degrees, we are 0. Sine is not up or down, it's 0. At 90 degrees, sine has its maximum value of 1. Okay, at 180 degrees, we're back down to 0, or 0 on the way down. At 270 degrees, we're at our minimum. That was at -1. And then 360 would be right back up to 0, or 0 on the way up. Okay, and just like we talked about with the unit circle, that it just keeps going around and around and around, this pattern is going to keep going. Okay, 0 on the way up, then we're at the top, then we're at 0 on the way down, then we're at the bottom. 0 on the way up, now we'd be at the top, 0 on the way down. If you wanted to keep going, we'd be over here. Reverse the pattern. Okay, and now we're going down, so -90, we'd be at -1. Think about our unit circle with negative rotations. -90 would put us down there. And -180, we'd be at 0. Okay, and then you're going to do your best to smoothly curve this out. Okay, this is a sine curve, or a sine wave. One, make it look like, well, that's not a very good one. Most of those are pretty good, though. That was a little rough. And it keeps going forever and ever like that, following that pattern. And that's going to be our most basic thing. Okay, sine goes forever left and right, so our domain will be all real numbers. And our range, the highest we get is 1, the lowest we get is -1, and we keep bouncing back and forth between those. Okay, one full cycle or period would be starting at 0 on the way up, back to 0 on the way up again. 360, a full circle. And then we'll learn some more fancy words later on. Okay? Alright, so that was sine. We're going to do the same thing for cosine. If I can turn the page. And we're going to think about cosine in radians. Alright, so cosine's max value is 1 at 0 pi. Then cosine, remember cosine is left and right, cosine would be 0 at pi over 2 and 3 pi over 2. And the smallest value for cosine is going to be negative 1, and that happens at pi. Okay? We're thinking about pi, radians. So I start at 0. Where is cosine? Cosine starts at the top of the wave. It starts at max value at 1. Pi over 2, we're 0 on the way down. Pi, we're at negative 1. 3 pi over 2, we're 0 again, but now we're starting to come back up. And at 2 pi, which is the same as 0 pi, we're back to 1. And there's one full cycle or period. Okay, the pattern keeps going. Now I know that looks like a V. We know it's going to make a curve. Curve it out. Don't make a V. Pattern is going to keep going. 0 dot, negative 1. Reverse, reverse. 0 dot, negative 1. And then do your best to kind of curve that out. No sharp edges. You're just starting, so don't feel bad if you're not. Look at me, I've done this for 20 years and mine still isn't perfect. Okay? Just like with sine, our domain is going to be all real numbers, and our range is going to bounce back and forth between negative 1 and 1. And then the fun one. Tangent. Tangent is sine divided by cosine. And I left one of them off. 0 pi. So at 0 pi, sine is 0, and cosine is 1, and 0 divided by 1 is 0. No sweat. Okay, pi over 2. Sine is 1, and cosine is 0. And we can't divide by 0. At pi, sine is 0, cosine is negative 1. 0 divided by negative 1 is 0. Okay, 3 pi over 2. Sine is negative 1. Cosine is 0, can't divide by 0. Okay, we'll finish it off. 2 pi will be 0 divided by 1 again, which is 0. So at 0 pi, we are at 0. My next spot over, I can't divide by that. Guess what that means? Just like when we were graphing polynomials, when we divide by 0, can't divide by 0, we had asymptotes. And then at pi, we have another 0. And 3 pi over 2, can't divide by 0 there, that's another asymptote line. Okay, and that pattern keeps going. We'll have a 0 dot. We can back it up to negative pi over 2. Have an asymptote line. The other trick for tangent, okay, tangent goes up left to right. It's going to look a lot like an x to the third graph, kind of, I guess. The other trick for tangent is that halfway between 0 and pi over 2, which would be pi over 4, then we're going to be up to 1. And halfway between, at negative pi over 4, we're going to be down to negative 1. And I know that looks like a straight line, but just like the other ones, we got to curve it out as best you can there. And then we're going up with the asymptote and down with the asymptote. Okay? And we'll probably need to do that. We'll have to have at least one of them, I call it fenced in. One of them fenced in with the asymptote lines. And have to have the dot. Okay, and then the other one we can maybe just freehand. Now this one's kind of flipped. Our domain is going to be special. X is not equal to pi over 2 plus, what's the gap here? 1 pi over 2 to 3 pi over 2. That's a gap of 2 pi over 2, or pi n. We'll talk more about that later. And then our range goes up and down forever, so that one's all real numbers this time. Okay, so again, very brief intro. Just want to have that groundwork set, and that will help our actual first day of graphing go super smooth. All right, thanks for following along and filling that in with us, and good luck next time. We'll see you later.